Hi, this is Pooja Ahuja from University of Florida CISE department. I've taken this course pattern recognition under ECE department, and my project topic is email spam filtering. Electronic mails are a popular and reliable way of communicating and messaging over the internet. Emails are often used by malicious users to send bulk unwanted spam emails to users. Emails can have a few malicious purposes like misleading advertisements and spreading malware. I got motivation to select this topic since spam emails have been increasing a lot since the last decade and a half. Popularly used email systems like Gmail, Yahoo, Outlook have been storing junk folders just for storing the spam emails, so it is becoming a high priority problem and it can be solved by email spam filtering. What is a spam? Electronic spams are the unwanted messages which are used for advertising or threats by misusing of email systems. Email spam is the practice of sending unwanted email messages, frequently with commercial content in large quantities, to an indiscriminate set of recipients. Throughout the project, the index terms which are being used are spam, which means the practice of sending unwanted email messages in large quantities; ham, which means the emails which are genuine messages and not spams. Spam to ham ratio is the ratio of spam emails to ham emails. False positive means an email that has been classified as spam even though it is a legitimate email and have been classified as spam by mistake, so it's called a false positive. Error rate, the number of emails that have been misclassified by the algorithms, is the error rate we see for different algorithms. The algorithms used for this project are KNN algorithm, Naive-Bayes theorem algorithm, and support vector machines algorithm. Naive-Bayes classifier was proposed by Thomas Bayes. It is a supervised learning algorithm based on statistical and probabilistic learning method. The Bayesian classifier determines probabilities of the outcomes by assuming a probabilistic underlying model. This shows the different kinds of probabilities calculated, like if the message is spam, knowing the presence of a given word in it, or if the probability that a certain word appear in spam messages, the overall probability of a message being a spam, the probability that a certain word appears in ham, the overall probability that a message is ham. So these are the different terms used for that. Steps taken for execution. For Naive-Bayes theorem, the first assumption we make is these continuous values are distributed along the Gaussian curve. Then we calculate the mean and standard deviations, find the variance, and according to the formula, which is 1 divided by square root of 2 into pi into sigma square, the whole probability gives out whether it is a spam or not. The implementation results of when I implemented my algorithm using the UCI dataset, it gave me an average execution time of 1.8 seconds for Naive-Bayes algorithm. Accuracy rate in average was 82.6%. K-nearest neighbors algorithm. It is a non-parametric method used for pattern classification. All computation is deferred until classification. The neighbors for the data points are taken as a set of objects whose values are known. An appropriate value of k is chosen. We consider k neighbors for each point. Here, k is predefined. This is done in the classification phase of the algorithm. Then, the training set contains the most frequent class values. The steps to implement this algorithm would be: first, make two sets out of the data. First would be training and then testing. Set the value of k. Calculate distance of all points belonging to t's from the given point Sort and select the closest k distances. Discover the class with the highest frequency amongst the k points selected. My findings were based on the values chosen for k. The values I chose were 1, 3, 4, 9, 13, 23. In the results, the average value of accuracy was 76.37%, and average execution time was 306 seconds, 306.523, which is long. Though it is the accuracy is closer to naive Bayes algorithm, the execution time is much higher. The effect of k. It is observed from all the findings that accuracy is higher for lower values of k, while higher k implies higher execution times. SVM or support vector machines algorithm. These are supervised learning models. They can identify and recognize patterns within data after analysis. There can be multiple separators between two data classes for two classes with linearly separate build data. If it produces a hyperplane on a high dimensional space, on an infinite dimension space. The points on the two lines marking 1 and -1 are support vectors. As you can see, there are two classes here, and there are three hyperplanes, H1, H2 and H3. The purpose would be to remarkably optimize the marginal space between the two classes. As we can see, H1 is not doing that, but H2 and H3 are separating the two classes. H3 is more preferable since it is keeping an optimized margin in between them. The vectors that define the hyperplane are called support vectors. The margin of the classifier is determined by the distance from the decision surface to the closest data point determined. As you can see, we try to optimize the marginal distance between the two classes as shown here, between -1 and 1. So these are the formulas, how we derive about the same. The objective function penalizes for misclassified instances and those within the margin. The kernel trick, finally, as we see, we have to properly keep an optimal marginal distance between the two classes. That is the whole purpose. So the results of SVM show that the average execution time is 11.3 seconds, which is fast, and accuracy rate is 80.88%. The average execution time being faster, it is still less compared to naive Bayes theorem. Conclusion: KNN does not have accuracy and execution time as good as naive Bayes or SVM. Naive Bayes and SVM have almost similar accuracy rate. Since the running time of naive Bayes is much better than SVM, we say that naive Bayes is better than SVM, and SVM naive Bayes together are much better than KNN, which means naive Bayes proves to be the best spam filtering algorithm in terms of accuracy and runtime compared to the rest of algorithms above for the given data set. I have used UCI dataset here since it provides high volume of data. I would be explaining the working of my algorithms. The implementation would be shown next. So we already saw the working of the algorithms earlier. Now I'll go ahead and show you the implementation of the discussed algorithms. We'll start with naive Bayes algorithm. So Python naive Bayes.py. Here we go. So I'm using UCI dataset due to its high volume of data of 4601 rows. It initially splits it into training and testing datasets into in a ratio of 67 to 33%, as you can see. The accuracy of this algorithm came out to be 83.015%, and 2.18 seconds is the execution time, which is pretty good. Knife base has good execution time as well as pretty good accuracy. Let's go ahead and see how SVM algorithm implementation looks like. So Python multiclass svm dot py. It will generate two result files. One would have two columns of probabilities. The left one would be the probability of it being a ham. The right one indicates probability of it being a spam. So for the same row, if the right probability is more than the left probability, it means it's a 1, which means a spam. Otherwise a 0, which means a ham. The second result file will have all the 1s and 0s for each corresponding data, which will indicate whether it is a spam. It has more probability to be a spam or a ham. The execution time of this one is 11.1305 seconds, which is good but not as good as knife base algorithm as we saw. Might also be due to the high volume of data for the data set. We'll go ahead and see how implementation of KNN algorithm looks like. And it divides the data set initially, splits it into same ratio of records, 67% to 33%, that is 3065 records to 1535 records. It will take around 306 seconds, as we saw earlier in the results, for the results to generate. So skipping that much time, let's go to the results. It takes a while, as we know. It should come anytime. Okay, so here it is. The accuracy is 80.977%, while the execution time is 338.8169 seconds, which is pretty high due to the calculations and comparisons the KNN algorithm goes through for processing. So the high execution time is justified. The accuracy is good, but since the execution time is really high, we can conclude that knife base and SVM are more preferable than KNN. Also, in between knife base and SVM, we saw that knife base has better accuracy rate. So knife base turns out to be most preferable from all the discussed algorithms. Thank you very much for your time.